Hello everyone, I'm Dan Graham. I'm the developer of ETM, Event and Task Manager. Today I want to talk about how dates and date times are entered in ETM. I'm creating a new reminder, which happens to be a task, doesn't really matter, and I'm about to make an entry for the @s starting date or date time, which in the context of a task really is the due date or date time. The fact that it is currently 11:25 on Tuesday, September the 8th, will affect how my entries here are interpreted by ETM. Let's begin with some fuzzy parsing that ETM supports. The timestamp now is probably the most commonly used, and you see as soon as I enter the now, it interprets that as Tuesday, September the 28th, 11:25, which of course is the current time. Eastern Daylight Time, that's the local time zone. As another example, let me enter MON for Monday, and notice that that's interpreted as Monday, September the 14th, 2020. Well, where did that come from? Anytime you enter a three-letter weekday abbreviation, or for that matter, even the entire week, case doesn't matter, ETM is always going to interpret that as the next weekday falling on or after the current date that corresponds to the abbreviation that you entered. So if instead it's Tuesday, if I enter Tuesday, I'll get today. If I enter Wednesday, I get tomorrow, and so forth. Now let me talk about how ETM interprets numbers. Numbers representing month days, month numbers, or year numbers. And how ETM interprets these depends on two settings in the ETM configuration file. Year first and day first, both are set either to true or false. The default in ETM is for both to be false. Year first is false, day first is false. So with that in mind, let me enter, say, 9. And notice that this is interpreted as a month day, and in fact the 9th of the current month in the current year. So one number by itself is interpreted as a month day, if possible. The month day by itself is interpreted as belonging to the current month and the current year. Now if I added, say, well, let me go back and put a 1 first and then a 9. So this is interpreted now as the first number as a month number, and the second number is a month day number. So that's because of the year first being false and the day first being false. So either of these could be a month, but because day first is false, this gets interpreted as a month, and that is a month day. And since no year is specified, that's in the current year, 2020. If I added now 21, then it would be interpreted as belonging to the year 21 in the current century. If I wanted a different century, I'd have to specify the whole four-digit year number. Now all the examples thus far involve, well, almost all of them involve dates, but date time interpretations are similar. If I just enter a 10, I get the date. If I add a P, now it's interpreted as the time. 10 p.m. What date? The current date. And again, the local time zone. If I wanted a different date, then I can enter a month day, and you see I get Wednesday, September the 9th, tomorrow at 10 p.m. And if I wanted to enter, then it would be 10 p.m. on January the 9th in the current year, and so forth. You get the idea. Now what if these are all in the local time zone? Of course, it'll be Eastern Standard Time in January. What if I wanted a different time zone? I could enter at Z, and for example, U.S. Pacific. And let me go back and put the cursor in the time slot. And you see we now got the interpretation Friday, January the 10th, not the 9th, but the 10th, 2020, 1 a.m. Eastern Standard Time. Well, what's going on here? Well, of course, 1 a.m. Eastern Standard Time on the 10th is exactly the same time, really, as 10 p.m. January 9th in the Pacific time zone. So these really represent the same times exactly. What ETM does is whenever a time is entered, if it's an aware daytime, as this is, it will first convert the time to Universal Coordinated Time, UTC time, and then actually store it in the database as Universal Coordinated Time. Then whenever a date time, an aware one, is presented to the user in ETM, as it is here, it's always presented in the local time zone as the equivalent in the local time zone. So UTC times are stored. Local time zone equivalents are always the ones that are presented. Now the next thing I want to talk about is the difference between floating or naive dates or date times and non-floating or aware date times. Dates, of course, the first thing to notice is that dates always float. So 1/9/21, or of course the separator doesn't matter. I could have entered that as 1/9/21 that way using minus signs. Get the same January 9th, 2021. That is a date. It's always going to be a floating date. So that's always wherever my computer is on January the 9th. That date is going to, a task that's due on that date is going to appear as due today. Now notice that's true if I'm in the U.S. on January the 9th. The task is going to be due today. If I'm in Australia on January the 9th, the task is going to be due today. Even though the 9th in Australia is the 8th in the U.S. Now date times can be made to float as well. So for example, 10 p.m. on January the 9th, Eastern Standard Time in the U.S. can be made to float by just adding the time zone entry float. Now if I go back and look at the time, now look at the time zone abbreviations disappeared because it's not an aware date time anymore. There's no time zone information associated with it. So this is the way to make a task float. Now why would you want to do that? Well, maybe I want to take my meds at 10 p.m. every night, no matter what time zone I'm in. Then making that, adding the at Z float will cause that task to be due at the time I want it to be due, whatever the time zone. The very last thing I want to talk about is relative date time. So let me erase this stuff. And by that I mean entering things that measure time relative to the current moment. So let me enter, for example, plus 3 hours. And notice how that's interpreted. It's now 11:36. And so 3 hours from right now is 2:36 Eastern Daylight Time today. So that is just adding 3 hours to the current moment. What about minus 1 D, day. Now I get yesterday. So I'm just subtracting a day from the current date. I get a date, which is yesterday. I could alternatively add 2 weeks with plus 2W. Get a date which corresponds to 2 weeks from the current date. If I had, for example, if I received something that I had to reply to within 30 days, then I could always set a task with a due date of plus 30D. Now I can always specify a time as well. So for example, 3P sets 3 p.m. today, but 3P minus 1D would give me exactly 3 p.m. yesterday. Now the last thing I want to mention is that although all these entries that I've been doing have been illustrated in the context of providing an entry for the old @s starting datetime, they apply to any field in ETM, of which there are many, that call for dates or datetimes. What are some examples? @+ to add a datetime to the, or @- to exclude a datetime, or @u to add a used time entry for a specific date or datetime, @f to provide a finished datetime for a task. All those things involve either dates or datetimes, and the kinds of entries I've been talking about working in exactly the same way for all of those fields. Well, that's it for today. I hope this has been useful. Appreciate you watching this. See you next time.